now we can get started with what we have on the agenda for today. Let's have a look. Just before I'm talking about the agenda, the usual reminder of where you can find the previous sessions in the Ask Tom special series, typically in the Ask Tom platform. There are all the past sessions available as recordings for looking at your convenience. Okay, what do we have on the agenda for today? Renee is going to do a brief recap of the last session, the session we had in June, where we started to talk about how to work with point clouds that are stored in the Oracle database and managed there. Then we jump right into demos, how we can work with point clouds, demos that extend what we have done in the last session, also reaching out to the point of visualizing point clouds and also integrating point clouds in Spatial Studio in order to visualize point clouds over there as well. With that, I would like to hand over to Renee to start with her part. Thank you.
Oh, thank you, Karin. So yes, my name is Renee Wikestad, and I am quite new in the group for product management for Spatial and Graph. So this is my first Ask Tom session here for this group. I have been working for Oracle for many years, but I've been working in sales as a solution engineer in Norway. So to start, I will start to share my screen. Karin, could you see my screen?
Yeah, I can perfectly see it. Thanks.
Thank you. So last session, Karin was talking about how to load point cloud data and so into Oracle. So a short recap of what was in the last session is here in my notebook is loading point cloud data into the Oracle database, and especially the autonomous database is what I'm going to show in here. So what is a point cloud? So and the format for point clouds. So mostly point clouds are saved in LAS files. There is also other formats, but we will look into how to upload LAS files into Oracle today. Some information that's from the LAS files I will go through here as well, and I will also show shortly how to use this Oracle tool SQL Loader to load data into the database. But first, before you begin using SQL Loader and the LAS tool, you need to install them. So here I have said how to install them in, for example, Linux. What you need to set, since you're using SQL Loader from Oracle Instant Client, you also need to set your DNS admin to show how to connect to the database. And then here is how to download the LAS tools. And the next part, you also need to set then the LD library path to look so it finds the tools when you start to loading. So in this program, I had shown how to find information about your point clouds in the LAS files. So from LAS tool, you have this command LAS info, and by running it, you find information about your point cloud. You will see which kind of coordinate system you have, which attributes are saving in the LAS files, and also all other information you have from this. This is something we went through last session, but to show where to have this information and what to run before you start to upload it into the database. So when you want to upload into the database, if you're using SQL Loader together with the LAS tool, you need to have the table ready before you start to load. So here is how to create a table with all the information you need, as you have found out with the LAS info command. And after that, you can start to load. Here I am using a batch script to load the last file into the database. And this is all the parameters, sorry, from the last commando that I want to save into the database. You could use either X, Y, and Z uppercase or lowercase. If you use the uppercase, you don't use the raw X, Y, and Z values instead of the scaled ones. So here I'm using the scaled ones, so they are scaled to the coordinate system as I want to have it into the database. And also those attributes, if I have extra attributes in my last file, then you need to tell that in the parsing. And also, as you see here, I had a file name saved in the table in the database. So this is what I done here with the extra parameter as well, taking the file name, because I'm running this with the file name and control file as input.
René,
Yes.
just a question. Since you mentioned that there is a lowercase xyz and an uppercase xyz, can you point that out in the last info example you had before?
Yes,
Maybe
I have tried to point it out here, but it's not so very easy to see. But these scaled values, they are the offset of them are set here. But the uppercase X, Y, and Z are the values you see here, the raw data.
Yeah, okay.
So they are
displayed in the less info.
Yes, so when you're using lattice info, I also write a command, some text under here that's saying that the big X, Y, and Z is those who are the raw integers, and that the small ones are the scaled ones. But you filed everything with the less info commando. Less info, since I have less info 64 here, that's because of I'm running in 64-bit Linux, but if else you run less info instead of less info 64 if you're running on Windows or other systems. So back to this example. This was my control file with all the tables that I want to use with SQL Loader. And as you see here, when I'm running the commando, the shell script, I run it to standard output. So I don't save anything in any text files. I run directly from my batch script into the and reading line for line and directly into the database. So then after this is finished, and it's stored in the database, and you could then do a select and see all the data stored in the tables in the database. So this was a recap from what we did 1 month ago. So now I'm going over to tell more about how to work with those data in the database and how to plot, visualize, and so on. So this is the part where I have started today, is to show how you could visualize point clouds from the autonomous database. I will show how to visualize it in Python, and I'm only using this library because I had some issues in this data science about running this 3D library. So that's the reason why I'm only using Plotly here. But there is other libraries as you can use for plotting as well. So, but it's only to show how you can pick data from the database. So I'm starting here with importing the libraries I need in Python here. There is also this warning. I will come back why I have said that I don't want this warning, but I will come back to that in the paragraph. That's where it will come. Here I also have the connection to my database. So, and I also need to make an connection with an agent, since I'm running this SQL query and directly running it from the query into the Panda data frame. That's why I'm using engine here instead of only you can use Oracle DB with connection if you use cursor and other ways to read from the database, but this one was a good connection when you wanted to run with Pandas data frame directly. So then I write my query, since I have already uploaded the data with what I told from the recap from last sessions. So, and if you want to select the data, so in my table I have the X, Y, and Z and all the other attributes saved. So some of them I needed here for plotting, but what I find out that using those were not the easiest one to use together with this Python library when you're going to plot here. So instead, I went to the scale back to the raw X, Y, and Z. So that's the reason why I'm using both the offset and the scale value here to come back to those values. So and I also, when I'm using the library for plotting here, I needed to convert the color code back to a composite string format. So that's the reason why I took all these red, blue, and green colors and put it into one string format, as you see here. And I didn't take everything I had in the last file. I also wanted to plot only some of my trees. In this last file, it's a lot of tree in an area in Czechia. So here is some of the IDs of the tree, because there have been run some AI on the data, and I have added IDs for every tree in the last file. So that was some of the attribute that was added. So that's the reason why I have a smaller data set than the whole last file here, or the whole table in the database. So I'm only taking some of the data. I think it was around 8 million points in these files, but I'm using then around 500, 600,000 here in this select. So the next I do is to convert the data set to a NumPy array. And I took as you see, the X, Y, and Z, and the tree ID and the tree species, and the color. The next here is that I only looked at the first column in the NumPy array. And then I find out how many points do I have. So it was, so you see 581,000 points on that. And then I start the visualizing. And the visualizing is visualizing but I didn't use the color that I have in my data set. I'm setting the color to be colored by each tree ID, those who I have in the select. But that was the reason why I had this warning, because it was not the best way to for this library to have color ID set there. So this warning is because of the color, setting the color in the figure here. But I will show you how I will use the other colors after. So doing this, plotting this with the colors, I see some of the point clouds here, the tree I have selected, point clouds for those, but instead of using color for each tree, I'm using the color from my dataset instead. This is a bit more research intensive, so that's the reason why I tried first with setting the color that way. So instead of having color here, I'm using the color from my data set and use that as a marker here. And then when I try to plot the tree with those, then I have the color that is in my data set instead of for each tree. So you see more the tree and the leaves have their green color and so on. And then for plotting, it's quite expensive, as I say, for researchers to use all the points. So often it's better to use maybe a reduced data set. So that's what I'm doing here. I'm only saying, okay, randomly taking only a fifth. So reduced it by a factor of 5, so 20% of the data. And then you can see the plot with this reduced data set is a bit more dense. But that's what I'm doing here. And the next is that I'm trying to plot only for one of the trees. So I'm checking first which tree ID, which unique tree ID did I have. Find the center of one of that tree and made a filter. So I'm only looking for the filtered data set. And then I was plotting only one tree. So this is what I'm doing here, taking out one tree. In the next pile, I will show you how you then can go from this data that is stored in the database and then write it back to a LAS file. And also, I will go from LAS file to 3D tiles. The reason why I'm going to 3D tiles is that I will show you how you can also plot this in Spatial Studio. But for now, we need to convert data, point cloud data from the database into either 3D tiles or other cesium formats to show it in Spatial Studio. But hopefully that will be changing soon, so we can have directly plotting in Spatial Studio from the database. So what I'm doing here then is the same library then, but I know I also have with this LASPy library, since I'm writing back to LAS. Doing the connection, doing the selection again here. No, you see I haven't converted those. I'm using the raw data as they were in the table, but with the scaled X, Y, and Z, and I'm also using the color, each color code by himself. And no, I'm not using the plot library, so I don't need to do the string conversion and so on of the color code. So then I created a data frame, a geodata frame of the pandas data frame. And after that, I started to create the LAS file. So the LAS file, this is first creating the header of the LAS file. And then I was in the database, I have saved the offset, scale for each of the factor for each of X, Y, and Z. So that's what I'm setting here. The scales back to what it was in the beginning, and also the offset. This you could read from the and save as metadata in the database. Read from the startup last file that I started with. But I have already saved those in the database. But you can easily read them from LAS with LASPy as well. And then I setting the minimum, maximum X, Y, and Z that you also see from LAS info in the header of the LAS file. So everything this is from, if you read LAS info with the LAS file you start with, you will find that that's normally what you have in the header of the LAS file. And then I'm writing all the data, and as you see here, everything I have in the database is then back to what I need back in my last file. I also need the color codes, as you see here, and I also wanted the extra attributes. So those are also with me here. And then I have in writing a LAS files. That's the name of my file out here. And after I have make this back to a LAS file, I will then convert it to this 3D tile set. So here I'm using Pi 3D tiles. That's a converter or a library that you could use to print from LAS and to tile set. And this is the way I'm using. Input is the LAS file, output is the tile set, and input was the coordinate system for, or the projection of the point clouds I have in my database, and output I want it in this format because I want it to be showing in this 4978, which is a 3D format that it will be picked up with. And after I had converted it, it was in this path, this map, that I needed to zip everything into one file. So this is zipping it to have one zip file to run and upload in Spatial Studio.
René, can
Yes.
I jump in for a second? There is a question that Martine has asked whether it's planned to display the data directly in Spatial Studio without first converting it to a LAS file. That's certainly something we have to work on. What we already support is using cesium files and cesium formats to directly load those as data sets in Spatial Studio. And what we're doing here is having this step of creating a LAS file in between, which hopefully will not be needed later on as an additional step to create the cesium formats, which we can display in Spatial Studio. But that's something we will be announcing as soon as the feature is available for Spatial Studio. And also the feature is available in the database to create 3D tiles directly from point clouds, so we avoid having these intermediate steps.
Yeah, I found out that going through LAS now, it's maybe other possibilities as well, but that's what I found out was to use LAS as a file format as a middle between the point clouds in the database and 3D tiles. So then after I converted and compressed it to a 3D tile file, then I could go to Spatial Studio, and if you go to dataset here, I have uploaded those here. So create dataset, go to cesium format, and then you see you could either upload this CZML files or tileset, and I'm uploading those tileset here that I created in the zip file. So it's only to upload the zip file here. And then if I go back to my project, as you see here, here is the same trees that I was plotting in with this library in Python, but now I have downloaded the file set to this here. But I have also downloaded everything from my the three files I started to upload in the database. So those were three different LAS files that was uploaded to the database and then written back to LAS files again, and then converted to these 3D tiles. As you see here, all those green trees are those who have trees ID. All those who don't have color here, they didn't have color code, and the tree ID was 0 for all of those, but all the other ones were those who were set with colors and with the tree ID. Those I was plotting was, as you see there, you cannot see them now because they are together also. They are the same as the other ones that were here, but I also had some other one plots I did. So here is some other plots, but as you see, this is everything, and this was only those three that I took in the first Python notebook I showed you. So, but you can go back and forward as you want. I didn't do anything when about the ground in my Python notebook because I only had the trees and some of the tree IDs, but in the file I uploaded to the database, I uploaded everything, and then you also have the color code for the ground here as well. But as you see in my this visualization, I don't have any surface or contours for the ground, so it seems like the trees are a bit up in the air, but that's because I didn't have any topology data saved here as well. So Karin, I think that's what I'm going to share today for my demo, but you also had something you were going to share.
Yes, I have. So just if you are asking where to find the scripts René presented, so the notebooks will be made public in my GitHub repo for the Ask Tom series. I'm going to share the link to that GitHub repo later on. So hopefully you stay until the end. And then we can share it over there. And the recording, as we said, will be made available via the Ask Tom platform as well. Okay.
Is there any questions before I take this?
Good questions. Time to check whether there are any questions. I can't see any in the Q&A, but maybe it's time now to step up and ask questions about what René has presented. I think there was a question in between about what you used for the development. So if you go back to the Python scripts and the Python notebooks,
so
maybe...
this is, yeah, so I'm using Oracle Data Science Service, also OCI Data Science Service. This is a free service that we have in OCI for writing notebooks and running MLOps and so on, but you only pay for the infrastructure you are running your notebooks on.
Okay, for the compute resources.
The compute resources are what you pay for here, not anything else. But this is an OCI service.
Okay, perfect. Then let me just briefly close the window to get rid of the additional noise. Okay, good. So let me start sharing my screen again. Okay, so I'm going to stop that part here. What I'm going to share today are two things I briefly mentioned last time when we talked about point clouds, what we can do with point clouds once we have those in the database. So there are several functions, procedures to query and manipulate point clouds. And I've picked out two of those functions or procedures. The one is a new one, which we introduced in 23AI, which is the PC underscore difference as part of the SDO underscore PC underscore PC PKG package, PSQL package. So this is the first one, what I want to present. And there is another function, PC clip, or clipec, which is the actual name of the procedure in the database package. But for that, I've prepared two SQL scripts, which you can find here. But before I'm going to start with the actual SQL, I just want to briefly go through which steps you're going to see. So first is I just check the underlying data using the last info, the same command that Renee has used in order to get the information out of the last file. Then we're going to use the last tools to convert the last files to texts, extracting the information I'm interested in, and loading those later on into the Oracle database, first into a staging area, and the load that I do, where I use SQL for the load, so you can see different tools to work with. The next thing is that from the staging table, we use the data in the staging table to create the point cloud objects in the database, and then calculating the difference between two different point clouds. And as the data sets to generate the difference, I've picked two loss files that are delivered within that GitHub repo, the Peter GitHub repo. They have a data folder where they share some simple loss files, and I've picked the Palm Beach pre-hurricane last file and the post-hurricane. And what I want to do is actually comparing the two data sets using the features inside the Oracle database. And in order to get an impression of what the actual loss files contain, let me check where I am. Okay, so here we go. So in order to show you how the content of the loss files look like, I'm using last view as part of the last tools. And I actually had this all open up already, but let me start with the pre-hurricane last file and then loading all points. And what you can see here is when starting the actual command, then you can see that there is the last file displayed here. And you can also rotate the 3D image to see get a better view on what the last file contains. So this is the part where Palm Beach is pre-hurricane, and then let's have a look at what it looks like after the hurricane. And yeah, just having the two data sets, looking at them separately is probably not going to reveal much. So that's why there are functions like comparing two point clouds and figuring out which for each point within a point cloud, what are the neighboring points in another point cloud data set. So that's what we are going to do. So let me stop that part here. Okay, so the steps I've done is first checking the last info, and what you find when checking the Palm Beach pre-hurricane last file is that it does not reveal any information about the actual coordinate system, which makes it quite difficult to plot it or to do the same steps that René just explained and plot them on a map in Spatial Studio, because for plotting them on a map in Spatial Studio on a base map, we need coordinate information, coordinate system information coming along with the Palm Beach or with this last data set. So we can't do the same steps here as René has shown, but we can do something else, and that's what I'm going to explain. So first step. The next step is that we convert the actual LAS file or LAZ file, the compressed LAS, into text, and I'm going to just extract XYZ from that those LAS files for both data sets, and I'm using those XYZ information in the database, or I want to load this information into the database and then use only XYZ for plotting them on a 3D scatter plot later on. Okay, so what else do we need to do? So first is I want to have an input table, or I want to set, or what I've done is setting up a few table structures. One table structure, actually the most important, is first to load the data into a table called LiDAR scenes, which has a column point cloud that is of type SDO_PC. Then we have the a table structure for the points that represent the pre-hurricane situation, one that represents the post-hurricane situation, and then there is a result table where we do the comparison between the pre and post hurricane situation. And what you will see what we need for the functions to create the actual point clouds, and also doing then the calculating the difference between them. We need those table structure where we have columns called val_d1, val_d2, and d3. There could be more depending on the extracted values from the last files. But as I said here, I'm only going to extract XYZ. This is what will then be represented as these three columns in the table PC input tab. Could also be a view, just for, yeah, doesn't matter whether you created a table of it or a view. And here is the actual LiDAR scenes point cloud table, which contains the objects. And in the end, you will see that it will have two point cloud objects, one for pre and one for post-hurricane situation, the post-hurricane situation, and belonging. Oh, yeah. So, okay. Then the actual upload of the extracted text information we do in this staging table PC input tab, yeah, or in tab. And I'm going to use SQL_CL for that. Here are the settings for SQL_CL in order to properly load the data. So the delimiter is a semicolon, which is matches with what I've defined further up here. When I use last to text 64, I've defined the delimiter for the text file that is created. And this is also defined here as setting for SQL load or SQL_CL and the load function in SQL_CL. The actual files don't have a header, so the column names are set off. And then we are going to start loading the two text files into the staging table, one after the other, and with some processing in between. So here I'm going through the first data set where we don't have any data yet, but I'm going to use I'm sorry, here I'm loading the data, and once we have loaded the data, you can see here the 2.5 million points. Those are then in the table PC input tab. And then we're going to use that table with these three columns, val underscore D1, D2, and D3 in order to set up the actual point cloud table. And as I said before, we have already defined the structure for the point cloud table LiDAR scenes. What we don't need to set up in advance is the resulting table, which contains the the actual points for the LiDAR scenes representing the pre-hurricane situation. And by creating the point cloud, we also define which ID this point cloud object will get. And then running this create PC unified, we can set up the point cloud table with the point cloud object, and the actual points are stored in this second table here. So let me just see whether this is still available. I think okay, so don't worry, I've started the visual code in between, so I need to do the reconnecting to the database. But let me go further down to explain the rest of it, and then we can check a few things in the database. So here we have the LiDAR scenes. Then let me do that using a different tool, which is where I have the connection already open. So here we have the tables. LiDAR scenes should have 2 point clouds of pre and post hurricane, which is a situation after I've done the second load as well. And here are the point clouds for the pre-hurricane situation. And if we go back, this is the result now. Then we do the same again for the post. This should actually be post-hurricane situation. Oh, there is an error. Okay, so should be post here. So doing everything back and forth did result in this mistake here, but yeah, this is then stored in the PC tab, which I've truncated in between, as you can see here, to contain the second data set. Then we create a second object in the LiDAR scenes table, a second SDOPC object, and the actual points are stored here in this table, which you then see here. And now we have the 2 point cloud objects in the LiDAR scenes table, and then the related data tables, which contain the actual points of in the point cloud as in the flat structure, flat table structure, those are splitted onto the two different tables, representing one table representing the pre and one table representing the post hurricane situation. The next step then is to calculate the difference between the two point clouds. And for that, we use the procedure PC_difference. And this procedure takes LiDAR scenes, which has the two point cloud objects inside the column point cloud. One is identified by the ID 111. The other one is identified by 222. And then the result is written into a new table called LiDAR scenes XYZ diff pre post. And this is created automatically by this function. So we don't need to set up the table structures in advance. And we can also define a query window that is using as an additional filter for the points in the point cloud. And this filter here is actually taking all the points from the point cloud into consideration, so it doesn't filter out any points. And after we have done this, then we can check the results of, we can actually copy both of it. And by running the first thing, here we see the points, the resulting points for the difference and the actual points in this difference data set is this number of points that are different comparing the two data sets. This is the first part, and I've also set up an OCI data science notebook in order to work with those things. And what you can see here is that let me put that out of the way, that I'm connecting to my autonomous database here. Then I select everything from LiDAR from the data points tables. So the XYZ pre and XYZ post down here, and create data frames from it, or from those, since I have two. And then going further down, I also create a data frame for the difference here. Where do I have it? So where is the difference? Oh, there seems to be a mistake here as well. So it should actually be that difference repost here to create that data frame. So, okay, so good. But the rest of it is kind of similar to what you have seen before when René presented to use Python for visualizing the data sets. So we are using external libraries to do the 3D plotting. Where do I have it? Let me go further down. So here we go. So we use Plotly in order to create the 3D scatter plot. And what I'm doing here is actually the same what René has done. I'm reducing the actual data set because it takes too long to represent millions of points. I'm reducing it to 1/10 of it, and then using this reduced data set in order to plot it here. And this is the scatter plot, or should be the scatter plot for the difference. It doesn't look really as nice as the result you have seen with the trees, because those you can much better identify and compare within their structure than the result of that difference data set between the two situations for this area scenery in Palm Beach. But this is actually the way how you can do it, creating the differences, then turning this into pandas data frames, and then using the plotter plotting features of the Python libraries, and show them either in Python or, as René has explained it, using or converting the data set into 3D tiles, and then loading the 3D tiles in Spatial Studio and display it over there. The second function I've prepared is kind of similar to what you have seen before. What we are going to see there is a different function where we clip portion out of a point cloud that is related to a geometry. And just going briefly through this, what I've done here, I'm creating a synthetic data set with 3D points as geometries. So I'm setting up a table with a geometry column that is of type geometry. Then I have a function here that creates coordinate values for a certain area, and this happens to be a point quite close to where I live. And here we have a proper coordinate system for 3D data, which we can then use to store the geometry objects. Then we can also define the spatial index for that table. Since it is a geometry object, this is what you can see here. Then again, we will have a staging table that contains the XYZ values of those geometries, and the actual values we extract using this dot notation from the geometry object. We extract the point information, and here the X value, the Z, Y value, and the Z value from the geometry object. Then we store those into that synthetic 3D points table. I'm sorry, we store them in this points input tab. We selected from that synthetic 3D points table, sorry. And the next step is we again set up point cloud table having a SDOPC column, also called point cloud. And then the next step is again using the create PC unified to create the actual object within that point cloud table synthetic 3D PC. And from that, we have the next step where we extract parts of the point cloud that fall into that geometry, which I've defined here as query window, and extract those from my actually point cloud data set and store the result into a table that is called PC underscore script underscore result. This result table you do not need to define beforehand. It's created automatically, and in the end, what you can find out is the resulting data set from this clip operation, which is represented in that table. And if you look at the originally, we had 1 million points, and this clip operation create almost 240,000 of the points that fall into that area. So there are two functions that can be used in order to do processing, querying of point clouds, and then you have the next step in order to visualize the data sets, or you then go ahead and use the resulting data sets to do the next type of data processing or querying in your analytical workflow. So that's up to you what you need to do in order to receive the results you're looking for. Okay, so this is what we wanted to present to you today in terms of demos. And let me check whether there are any more questions.
No, I don't think there are any more questions. But what I didn't mention was that when using the flat format to store point clouds, since we have two different formats that you were talking about last time. So, but for this demo, I was using the flat format to storing point clouds in the database, and the same you did as well.
Good point. Good point. Yeah. Last time I explained that we have different models how to store the point clouds. We talked about the SDOPC, which is an object or a complex complex object type to store the point clouds, and this is either related to a table containing the actual blocks for the point clouds, or in our case, we have a data table attached where we have the points listed in flat files using XYZ and the additional columns for further attributes that we have extracted from the last files. Good point, René. Yeah.
There was a question now.
There is I've just seen that popped up the question. Let me check. Q&A, yeah. So Martine wants to know if I have a static geo object that is regularly scanned via point cloud, how can I show the difference in a way that clearly highlights the changes compared to the previous scan? That's something I think I need to think about first. It's a very long sentence question. Maybe Martin, can you just briefly rephrase it? Maybe that I can better understand it. So if you unmute yourself. Otherwise, I would take the question and so what we've seen is the difference. That's true. Yeah. And what do you want to see exactly? So what we can actually do, René showed that when you visualize the data sets, you can actually create a data set for the difference, and the data sets for the input point clouds, and you can visualize those using either different coloring, and then just create the different layers on top of a base map, and there you can see the different colorings indicating what is the change, what is the underlying data sets. Would that be a way to go, Martin? Okay, maybe we take this question offline so we can probably answer that, or figuring out with Martin what he exactly wants to achieve. I would like to thank you, Renee, first for your part in it, and then thank you everybody for joining us. And yeah, let us know if there are further questions. And Martin, will be coming back to you and discuss this offline. Okay. I forgot one more thing just to mention. We haven't defined yet the topic for our next Ask Tom session. Feel free to send us the topics you're interested in, or a use case, or whatever you would like to discuss with us. We are open to pick up your ideas and turn those into a session. Just let us know at least 2 weeks ahead of time. Otherwise, we will find a topic to present on September 30th. Yeah, and stay safe and enjoy the rest of the summer, everybody. Thank you.
Thank you. Bye bye.